Wait, I know how hard it is to find technical details on the Quant Network Overledger system. So today, I've made a video to help you guys understand how the Overledger system works at a very high level so you can explain it to, I don't know, friends, family, or hell, even the next door neighbor's cat if you'd like. So grab a coffee if you have a spare 25 minutes because you're not going to want to miss this video. Now, if you did enjoy the video or you wanted to support me, please go ahead in the description below and have a look at my Patreon. You might find something you really like over there. Otherwise, just go ahead and say good day to me. The Discord is down below. And of course, it's free as well. So again, grab a coffee, guys, and let's get started. At the highest possible level, Quant Network is a service provider and not a blockchain. Now, many people do confuse the fact that Quant is listed as a cryptocurrency and automatically assume that it's focusing strictly within the crypto ecosystem. Yes, Quant is an ERC20 token, however, it is not restricted in that sense. Quant is a business at heart, and it's a business looking beyond the crypto markets. It does leverage Ethereum like a business on the stock exchange might leverage their stock if they could use it, as a way to lock clients into their service for a predetermined amount of time. But all you need to know for now is that it's not used on the interoperability side of things, but I'll get to this very soon. Now, as you can see from the Quant Network overview, it's operating well and truly beyond the means of just crypto blockchains. Now, I know you're probably quite confused about how any of this is possible, so we'll revisit this infographic and others like it in a few minutes once I've broken things down. Now, at the heart of any revolutionary technology, there is always a unique mechanism or algorithm that differentiates it from the rest. It's something that powers it and is oftentimes the reason why it is so noteworthy. And for Quant, that is the Overledger. The Overledger is the world's first DLT operating system. It solves the problems of single ledger dependency by increasing communication between DLTs and allows general purpose applications, like dApps for example, to run on whichever ledger is connected to Quant. Now, it does kind of seem a bit like magic, yes, I do know. So let's break it down at a high level, seeing as I couldn't find anyone else on YouTube that actually explains it in a simple to follow way. Now, Overledger has been built on what's called the transport layer of the current version of the internet called TCP/IP. Now, it's modular in design with 4 distinct layers that allow for seamless intercommunication between any network it is connected with. Now, starting from the bottom, we have the internet protocol itself. Now, the reason Quant has opted to build directly on the TCP/IP protocol is actually very simple. All DLT networks, IoT devices, and basically any system on Earth is required to connect to the internet in some way or another. So obviously, by having a direct connection to the very thing that is mandatory to the digital age sounds like a very straightforward thing to do. Next, we have the transaction layer, represented in green by ledger 1 and 2, aka 2 different DLTs or ledgers. Now, to make it nice and simple for you, we could pretty much call one ledger Bitcoin and the other Ethereum. Now, this layer stores finalized, stored, or queued transactions on every ledger independently. Also, any and all operations required to reach consensus on a transaction are also recorded here. Now, this is things like, full nodes, light clients, and any other algorithm or mechanism used in that consensus process. Now, you can understand this like Overledger, simply recording a transaction status as it goes through ordering, consensus, and propagation, as well as however the consensus algorithm came to that agreement. Now, if we were to go back to the Bitcoin and Ethereum example, there would be a record of Bitcoin's transactions and a separate one of Ethereum's. Now, the main point I'm trying to make here is that Overledger doesn't try to combine the ledgers into a single record at this stage. The protocol simply lets the information from any and all individual ledgers just flow freely through this layer, picking out the information it requires, like a bear searching for its food in a stream of water. Even if a DLT had a testnet like Ethereum, these wouldn't cross over in this layer, so therefore in that hypothetical situation there would be a ledger for Ethereum mainnet and another one for the testnet. Now, moving up the stack, we have the message layer. Now, this is a logical layer, which pretty much just means it extracts and stores information on transactions from each of those ledgers underneath it on the transaction layer. So this is, for an example, the source, recipient, and the amount of the coin, or the script used, or the smart contract, or metadata, and all other types of information that passes through the different ledgers. Now, by extracting an extensive and broad amount of information, this allows Quant to connect with legacy DLT systems, as no one stone pretty much goes unturned. It just collects everything. Now, the transactions are encapsulated when they are added to the message layer, which means they can be added into a single channel together and won't interfere with one another. Now, the single channel is called the message layer. Now, you can think of this as a type of sorting factory for the post office. Now, just imagine for a second you have hundreds of conveyor belts running in parallel, moving loose packages of parcels and letters from every town in your country. Now, imagine a robot that could group all of the packages coming from one town, or in this case, the one conveyor belt, that are meant to be sent to the same destination together, and then add them into a single basket. Now, this basket is then dropped onto a single conveyor belt in the center of the room to allow for whoever is delivering the packages the convenience of simplicity. Now, the same process occurs with all other packages coming from the different towns, and they're all placed onto the one conveyor belt in the center of the room. Next, we have the filtering and ordering layer, and kind of like the name suggests, it just filters and orders information from the messages layer for the application layer. Now, it acts very similarly to a blockchain for what are called maps, or multi-chain applications that are actually built on the application layer. Now, maps are kind of like dApps in the sense that they rhyme, but other than that, they differ in a very, very big way. You see, Quant calls them maps as they are built on top of this stack and are therefore natively interoperable with all the DLT networks on this system. Now, we'll go into maps in a little more detail in a second when we talk about the application layer. However, for now, I want you to know that maps define the rules on how the stack interacts with the ledgers right down to the messaging layer. Now, what this fundamentally means is that when the multi-chain application is written, so too are the rules about who and what ledgers interacts with it and what information it requires. This is important as it's the filtering and ordering layer's job to collect the transactions and messages that are required for the respective map. Now, this filtering system is performed by a system called the Blockchain Programming Interface, or BPI for short. Now, the BPI is Quant's version of an API and, as mentioned, allows maps to interact with the Overledger and all connected DLTs. Now, the BPI identifies what specific information is required for each map, collects it from the messaging layer, and then the verification blocks are run based on the requirements predetermined by the application. Now, from here, the information collected, such as transactions or messages, are then placed into a verification block. Now, you can just kind of imagine this system as someone siphoning through an assorted packet of jelly beans who only eats the blue ones. They obviously know what they're looking for, and if they grab the wrong color and chew it, they're pretty much not going to waste any time spitting it out. Now, requirements for each map will obviously change depending on what type of application it is, which could be anything from a minimum amount of tokens for a deposit to unlocking a permission network with a non-fungible token, or even only accepting transactions to and from a particular address. Now, a verification block works similarly to a regular blockchain block. It's simply a part of a virtual blockchain dedicated to one specific map that combines any and all information intended to interact with that said application. Now, the information inside each verification block, aka the transactions and messages, are added in no particular order, with each block containing information from different ledgers. For the record, I want to say that the verification blocks are very, very important in this entire process. For a second, I want you to remember that each map has its own, kind of virtual blockchain on the filtering and ordering layer. Since any blockchain works by using cryptographic hashes to essentially secure and validate the order of the chain, every block has its own unique hash, which Quant uses to create hash pointers. Now, a hash pointer is simply a pointer to where the data of a transaction is stored, which is the actual verification block. And the hash pointer also allows for verification of such data if and when required. Now, the hash pointer is always sent to every ledger that interacts with that specific application or map, with the verification block acting as the proof across all ledgers involved in this process. Now, as you can imagine, the verification block is quite important, as some can involve many many different ledgers containing extremely valuable and sensitive information. Just to clarify as well, there is a so-called virtual blockchain for every single map on the Quant network, which allows each application to configure rules in its Genesis block on how it is to interact with the ledger defined in the application layer. Now, just to continue with the same analogy I used in the messaging layer, imagine another sorting robot sitting at the end of the single conveyor belt. Now, it's this robot's job to combine all the baskets that have the same destination into a single, larger crate for delivery. Now, the robot wouldn't care, obviously, what town the smaller baskets came from, as long as the destination was the same, they would be added into the same crate. Now, this single conveyor belt from the messaging layer would once again turn into hundreds more, each representing a store to deliver the parcels to. Now, the differences between the conveyor belts obviously now represent shops, not towns, and the baskets are now large crates containing all the baskets consolidated from every town that had sent the mail. Now, the final layer, the application layer, is where the multi-chain applications live, and as you can see from the screenshot, they're isolated from each other as well. Each map updates their state from the information in those virtual blockchains in the filtering and ordering layer, which of course have been validated at that stage. Now, each of these maps will need to define two sets of mandatory and optional rules that define how it interacts with the Overledger, other users, and also applications. Now, every single map will contain one or more so-called treaty contracts, which allow smart contract functionality across any ledger that a map requires an interaction with. Now, a treaty contract can be written in any programming language, which means that developers won't need to write a new smart contract on every single new ledger that they want to interact with. Now, by Quant allowing for well understood and applied programming languages like Java and Python, devs aren't really required to learn new languages, and businesses can save lots of money hiring specialized experts to write or reprogram contracts every time a new ledger is added to the map's interaction list. Now, additionally, a treaty contract is able to be duplicated and run on and in more than one location to protect the map against any unforeseen accidents, which may bring the application temporarily down. Now, if a treaty contract has already been established and a new ledger joins the network, only a single line of code needs to be added to the treaty contract rather than writing an entirely new contract on that ledger, even for Bitcoin or legacy DLTs that simply don't support smart contracts. And for those wondering, maps can communicate with each other by sending their messages to the messaging layer, and as long as those messages are compliant with the destination map, these will be added into a verification block and passed on to the intended application. So it's kind of a bit of a siphoning loop. Now, to finish my analogy with the post office sorting room situation, you can imagine the destination towns as the maps to which the crates are delivered. Clear as mud, right? Look guys, I completely understand if you're a little bit confused right now, as there aren't many people breaking this down on YouTube, even at a high level like this. Now, there are a plethora of finer details I could mention here, like how a two-phase commit is used to perform cross-ledger transactions in both the transaction and messaging layer. But if I were to dig any deeper, I would have to explain processes and terms that would need to be explained in those situations as well, which would just lead us to a 3 or 4 hour long video. And guys, honestly, let's face it, I don't think anyone watching my videos is a cryptographer looking for an exact solution to a problem. All right. Now that we have an idea of how the Overledger processes information, I'd like to quickly move on to how the Overledger gateways operate. Now, as you can see on screen, this is the image of the Overledger network ecosystem from a much more comprehensive example than what was shown earlier. Now, as you can see on the left, the Overledger is the brains behind the entire operation, which we have obviously now covered. Now, it's the gateways that are the connections to the various types of DLTs, including permissioned and permissionless networks, data sources, API sources, or existing legacy networks that are open to access in a scalable peer-to-peer way. Now, each gateway is access to a specific network or group of networks that open pathways to new data sources, markets, and of course, DLTs. Now, a gateway can be hosted by anyone wishing to participate in the network, whether that's a new user like you or I, or partners and enterprises who have connected their own DLT, for example. Now, the software that runs the nodes are so lightweight that they can be run on a personal PC or laptop, or even through your own cloud hosting provider. Now, the great thing about becoming a gateway node is that you're able to go offline if you so wish without being punished or slashed. You can opt to run your computer during the day to take advantage of your solar panels and turn them off at night, of course, to save a bit of money. Now, obviously, the less time a node is online, the less income it's producing, but you know the drill. Now, there are currently 3 tiers of hosting an Overledger gateway for a user like you and I. Now, tier 1 will allow the entity to host an Overledger gateway node in addition to 3 or more DLT nodes. So in plain English, what that pretty much means is that any user can host a gateway node and also up to 3 other nodes from different DLTs, like for example, Bitcoin, Hedera Hashgraph, and Constellation all at once. Now, tier 2 allows connectivity to the Overledger gateway, which is 1 node, and 1 other DLT node. So that could be anything like Hedera Hashgraph. Now, tier 3 only allows the entity to run the Overledger gateway node with no additional DLT nodes. Now, to participate in any one of these tiers, there is a deposit required as a license fee for joining the network, and it is important to note that this deposit is not redeemable. Now, for the sake of simplicity, let's assume that this is 100 QNT tokens, which, by the way, isn't confirmed or the verified amount. Now, after the initial deposit is paid and the entity has access to whatever tier they chose, there is an additional deposit called a variable deposit that is actually used in a pretty cool way. Essentially, imagine our deposit of the 100 QNT tokens, kind of like just purchasing a tier to become a node. Let's then say we decide to opt into tier 1, seeing as we'll have access to more networks and therefore can make the most amount of income. Now, the quantity of QNT tokens we decide to add to the variable deposit will determine how many function requests we can accept, which essentially just means that we can process more information to and from each node we operate, resulting in more passive income. Now, each time we process a function request without acting maliciously or returning faulty results, we receive a portion of our variable deposit back. Now, if we are a malicious actor and purposely alter the message or even return incorrect results, we have a portion of our stake slashed as a punishment. Now, in our example, I may want to deposit a large quantity of QNT into the very deposit because my goal is obviously to collect as many fees as I can by processing the most amount of function requests as possible. Now, since I'm connected to a total of 4 networks, the more in my variable deposit, the better, and the longer I stay online, the better. The important point is that if you opt to become a tier 3 gateway, you can only process functions that are related to the Quant network and not other DLTs. Likewise, if you do opt to host a node from another DLT in, say tier 1 or 2, you can only receive the functions from the Quant network and those specific ledgers. From this point, we can discuss a bit more about the enterprise hosted gateways as well. So we know that the users are able to have quite easy access to the Quant network by becoming one of the 3 gateways, and enterprises are more or less in the same position. Basically, enterprises are allowed to host a gateway directly from their own DLT to another network connected on Quant, irrespective of either network's privacy status. Now, for example, a permission blockchain built on Hyperledger Fabric could connect to a permissionless blockchain like Ethereum, but as for the other way around, well, that simply just wouldn't be possible unless the permission blockchain allowed it. Now, that basically means that a network like Ethereum could only attempt to send function requests to a permissioned network built on an enterprise blockchain like Hyperledger Fabric if said enterprise authorized it. Now, in every Quant article I could find, they direct you to contacting their team, so I couldn't pull too much more information in this section. However, I would assume that a minimum of 1 node per network would be required in this case, although it's possibly more. But guys, as my mother's always told me my whole entire life, never assume, because it makes an ass out of you and me. One more thing I'd like to mention about the Overledger gateways is what they're actually capable of interacting with, and it'll be a lot more than what you'd probably think. You see, up until now, I haven't really mentioned APIs or oracles, which is a little bit of a shame as these are integral to Quant and its underlying ecosystem. Now let's just very quickly revisit the Overledger network infographic. As you can see on the ends of the Overledger gateway nodes, we have the various ways Quant can interconnect the digital world via the gateways. Starting from the aspects we have so far covered, we have the enterprise blockchains that are able to build assets specifically for their clients to leverage the Overledger network, the various other types of DLTs that are independent and reflected by well-known cryptocurrencies, and payments which refer to the cross-chain interoperability via the maps and two-phase commits. Now, in the center of the infographic, we can see 3 additional integrations that overlap both the API and Oracle services. These are enterprise integrations, which include legacy systems, data, which references real-world stock and inventory, and APIs, which kind of just speaks for itself. Now, I don't want to spend an astronomical amount of time on each topic for brevity's sake, so let's just touch on the most important aspects without diving in too deep. I'll start with APIs. Now, the article produced from Quant by Luke Riley titled DLT Interoperability, What Are the Options?, outlines 3 possible solutions to the DLT interoperability problem, which align with the World Economic Forum's governance framework that propose strategic pathways to enable interoperability between legacy IT systems and distributed ledger systems. One thing you'll begin to realize about Quant is that they are a business looking to do business things. A top priority of theirs is always to comply with regulations and frameworks well before they're even established, which we'll touch on more soon enough. The article, breaking down the interoperability options that align with the WEF standards, compares cross-authentication, oracles, and also APIs. Now, if I'm just going to summarize the research, it was concluded that APIs are the leading approach to solve this issue, being suitable due to their proven technology, the ease in which they combine distributed ledger technology with non-distributed technologies, the way they can provide a wider array of user access and controls, and that they can be utilized by cross-authentication or Oracle applications to provide more resilience to their deployments. Now, as you can tell, APIs are no joke, and considering literally everything has an API nowadays, it's allowed map developers to be extremely flexible when creating applications. Now, websites, networks, phones and computer applications, banks, IoT devices, you name it, and it's probably API compatible. Hell guys, even blockchain and smart contracts have APIs. Now, the only thing that wouldn't have an API is extremely old hardware, software, or other digital data like the live price of stock and things of that matter. But seeing as APIs are integral to the communication between the front and back end of a smart contract, it's quite easy for Quant to leverage this and offer smart contracts from any blockchain the chance to interoperate with another. The implementation of what Quant is calling open source contracts will allow developers to connect any blockchain or API to the network, which is all based on the ISO TC 307 model, founded by none other than the founder of Quant himself, Gilbert Verderin. The implementation of open source connectors creates an environment best summarized like a kid in a candy store, because developers are able to pick and choose whatever API they need to communicate with using their map. Now, API communications are seamless, and basically everything somewhat modern and digital utilizes them, so I highly suggest reviewing the article by Luke Riley, which will be in the description if you need further details here. Taking a quick peek at this infographic, we can see that a hell of a lot of cryptocurrencies use APIs, which will connect Quant directly to them with a single API integration. Now, in saying that, oracles are still an extremely important part of Quant and provide the missing infrastructure for real-world data that APIs cannot. Now, for those who don't know, an oracle is a third-party service that helps connect blockchains to the outside world, which could be anything from, a price of a stock to the amount of physical stock in a store to even the results of a race. Now, basically, guys, they're pretty integral for the synchronization between the real and digital world, and Quant allows data providers to sell their off-chain data to the Overledger network by running their own Overledger gateway node. Now, a huge concern with oracles is that the information provided can be infrequent and even incorrect due to genuine mistakes or, malicious activity. To prevent these issues, the data sent from these oracles is signed at the very source, meaning the oracles do it themselves with security akin to that of banks, ensuring the data isn't tampered with as it's in transit. Now, there are multiple Overledger gateways collecting the same data from multiple Oracle sources, which are then aggregated, ensuring a constant flow of data that can be verified across different sources. Now, multi-chain oracles are also able to be used to connect services from different DLTs running in the broader Overledger network. Now, this could involve national voting, which could allow governments to upload an individual's vote to their database, which could be used by another platform, let's just say a smart contract on Ethereum, to verify the vote was registered, which may allow the user to claim an airdrop of some sort of tokens or something of that nature. Now, seeing as the quantity of API and Oracle services are likely to grow exponentially alongside Quant itself, there is no way a developer is going to know which resources he or she is able to leverage. Now, to solve this, Quant has created the Overledger Network Marketplace, which is an ecosystem of data holders and service providers that can advertise and sell services, data, APIs, and other off-chain or on-chain integration or resource. Now, the owners selling their data, who are also their own gateway operators, which we have discussed previously, would be able to set the rules and prices for the use of their data or service. Now, this includes customizing transaction fees for each service, transaction, or event that the customers use, which are paid for using the QNT token. Thank you all so much for watching this video. If you found it useful, give me a like, subscribe for more of these types of videos, and I hope to see you all on the next one. Take care, guys. Thanks again. Bye.